A very warm good afternoon to all of you. On behalf of Net Zero Alliance India and First View Group, I am Sakshi extending a warm welcome to each and every one of you on today's webinar Net Zero Energy Roadmap Building and Warehouse Sector. It is my pleasure to be here as your host. We would like to extend our gratitude to our presenting partner Sunshore for their immense support to help organize this event. Many thanks to our esteemed guest speakers and attendees for their valuable presence in today's webinar. Your active participation has contributed in making this event truly remarkable. May I now request Mr. Bhavesh, who is the head of Energy Management Section at ERDA, to deliver his keynote address on achieving carbon neutrality in commercial buildings case studies. Attendees are requested to post in their questions, which he can take up after his speech. Over to you, Mr. Bhavish.
Yeah, Sakshi, thank you for inviting me and allowing me to share whatever we have learned since last so many years. I'm Bhavesh Vasiani, working at ERDA, Electrical Research and Development Association, since last 18 years, and I'm accredited energy auditor. Uh, Sakshi, can you confirm that my voice and screen is visible clearly?
Yes, sir, your screen is visible, and yes, okay, it's on slideshow mode. Great. Please go ahead, sir.
Yeah, thank you. So we are since last 2 years we are continuously listening about net zero. So in this case here we are discussing about commercial buildings. Now actually earlier it was there for industries only, like energy intensive industries were targeted for energy efficiency and reduce their energy consumption areas and losses. And now we are trying to become net zero or become carbon neutral in all aspects. For now energy efficiency, Bureau of Energy Efficiency has also involved commercial buildings also in their energy intensive sector. So first step towards becoming net zero is first attack should be done on energy efficiency, on which we are discussing some case studies. So in this something we will discuss initial introduction about PET scheme of Bureau of Energy Efficiency, then some one slide for methodology of energy conservation, how to find energy efficiency opportunities, and few case studies to have an idea that how we can start our journey towards net zero. So as far as PAT scheme is concerned, it is a performance achieve and trade scheme. Once industries and buildings, commercial buildings, all they have been given some targets of specific energy consumption. And once they achieve their target, they are given 3 years period, which is called a PAT cycle. So in 3 years period, they have to achieve some target of a specific energy consumption as per their baseline study. And once they achieve the target, they will be rewarded as energy efficiency certificates. So this is the way how PET scheme is operating. In this, we can see four quadrants. So here we can see energy saving certificates are issued. In this case, energy intensive industry or building has achieved their target. This one was their specific energy consumption target, and they have achieved better than this, means they have reduced their specific energy consumption. In that case, they are given some energy saving certificates based on the calculation of difference of this specific energy consumption. If they do not achieve their target and achieved specific energy consumption is higher than their target, then they need to purchase energy saving certificates from the market. If they do not means they are equal to their target, then no buy, no sell. But compliance is being considered. But it is an obligatory requirement as per Ministry of Power notification. So if you do not comply, it will be penalized heavily. So this is how PET scheme is operating since year 2015, or actual operation was since 2016. So recently in the I think commercial buildings are in their first PET cycle. Now, the same paid scheme is going to be converted into carbon credit scheme. Now, in next year or within 2 years' time, all the energy efficiency certificates or energy saving schemes or energy trading policy will be converted into carbon credit trading scheme. So this energy, whatever energy will be saved by a user or a builder or maybe by an industrialist, that will be called as a carbon credit. So those difference in energy, specific energy consumption will be calculated in terms of carbon credit certificates. So that trading will happen across the country or maybe across the globe after implementation of this scheme. So these carbon credit certificates can be purchased or sell, we can sell it in the open market as per the market value. So minimum at present the minimum value of this certificate is 1800 rupees, and it will rise as the time goes and these policies are becoming more and more stringent. Apart from that, there is a green credit rules also under pipeline. So they are going to merge all the areas like energy efficiency and renewable energy, and ultimately carbon capture technologies and green hydrogen, and all these areas wherever there can be a reduction of carbon emission, those all will be rewarded with some financial mechanisms. These are various schemes for that. And as a whole, a user will identify that in which area they can focus on. But as far as energy efficiency is considered, it is the lowest investment area where industries or consumers can or builders can reduce their energy consumption by these measures, and then they can do further investment in area of renewable energy or any other possibilities. So how this can be focused is the way general methodology or general approach for that is, initially we need to collect the preliminary data of commercial building or warehouses. The preliminary data includes their electricity bills, if fuel is being consumed, that bills, and then what is the actual requirement, where are the energy guzzlers operating, which areas, those can be identified, and further understanding of those electrical and thermal consumption will give some identification of location or target areas where we should focus more. So then measurement of those energy inflows and outflows should be done. It can be instantaneous, or in case of buildings or warehouses, now they are going for IoTs also. So continuously BMS also they are installing, so continuously they can monitor that data. But we have observed that lot of data is coming on their desk, even though they have installed this online energy management system also. But the utilization of that data should also be done to find out where there is a possibility, like energy side, input side energy consumption, voltage, current, power factor, kilowatt, harmonics, everything should be measured. And output side, whatever what is the temperature, operating temperature in various conditioned rooms, that should continuously be maintained, measured. What is the occupancy level in various areas. So all these parameters will give the possibilities where energy can be saved. So ultimately we give various recommendations based on the identified measures, short term, medium term, long term. So initially low hanging fruits can be targeted to go for such kind of reduction, to have first confidence in this. So how it is possible? We will discuss one or two case studies that how it is way forward in this method to save energy or to reduce the carbon emission. So this is one example that first we need to identify that which are the energy guzzling areas. So here we can see that in this case it is a one commercial building where the majority of this is the normal case for most of the big commercial buildings where most of the energy consuming area is being done by this air conditioning units. So this is coolers and AHUs and chiller and chilled water pumps. All this will consume the major part of this energy consumption of total building. Uh, and other than that, elevators and UPS inverters, if the data center is there, then there will be a major consumption from this side also. Of course, the zero discharge in water is also required. So that is also nowadays is being focused. So STP, ATP, or water reuse, how it is being done, that is also an area where should buildings should be focused. So this is indication that this way we can identify that which are the areas, then we can focus how it can be optimized further. So in this case, a major area is chilling system. So in which first is the utilization of AHU, and then another is area where distribution of chilled water and pumping system. Pumping system will be consuming, AHUs will be consuming, and then centrally chiller compressor. These will be consuming at highest, then lower than that the pumping system, and further lower will be on AHU side. But reduction or optimization at AHU will reduce the make energy saving in this and this both. So reduction in optimization in chilled water will reduce the energy saving in this. For the specific energy consumption reduction in chiller compressor will optimize the performance of it. So generation, then distribution and utilization. So in this way, we can identify that how each and every equipment is performing well or not, and also the supply and user and requirement are matching or not. Both way we can find the saving. First is to performance improvement of individual equipment, and second is to match the supply and requirement. There should not be any difference. Higher supply with lower requirement will make a loss in the system. So in this case, what is happening, we will understand from one case study. This building has two chiller units used for temperature control of some working area, and normally we use AHUs which supply cold air or chilled air to the conditioned area. Air is taking chilling effect from chilled water. Chilled water is coming from the chiller compressor. So normally this is the methodology measurement of refrigeration effect. At AHU side, we measure the TR developed at AHU, means heat load developed at AHU by measuring temperature, relative humidity, and airflow. Similarly, we measure the complete energy efficiency ratio of the complete system by measuring chilled water TR also by calculating or measuring MCP delta T, means measurement of flow and temperature difference across the system like evaporator or condenser. And net refrigeration effect on output side is being measured for in case of chiller compressor. Of course, input side we measure the power consumption for all the equipments like chiller pumps, fans, AHUs. But output side, this will be the method of finding out the output. So this is the way how measurements are done. Like in this case, there were two chillers. One is old and another is new. So here, chilled water, cooling water flow rate, chilled water temperature difference. So this is the direct TR developed. So kilowatt per TR is calculated for this old and new chiller. You can see which is expected for from old chiller, it is consuming higher or double than the new chiller. So it is not only the case of aging that this is new so performing well and this is old this is performing bad, but we can find out the areas due to which this specific energy consumption is getting affected, and then those rectification of that can optimize its performance near to or somewhat poor than new chiller. So in this case, detail the complete circuit was done, how the chilled water is going through these lines. So line scaling were observed. So it was indicated that in the condenser tubes also, or the water quality and environment is not good. So due to which the scaling was observed, and the cooling water temperature difference was also indicating the same. So heavy scaling was observed on cooling water and chilled water line. This creates falling in heat exchangers of the chiller unit. This reduces the heat transfer in the unit. Hence, it is necessary to clean regularly. So this should be the part of the maintenance practice. That at least condenser tube cleaning should be done at interval of at least 6 months. Now, falling in the condenser will directly affect the power consumption of the chiller compressor. This is a thumb rule. Improvement in temperature of evaporator or condenser will affect the power consumption of chiller directly. Similarly, cooling tower is always there for condenser water cooling. So ultimately, chilled air heat load is transferred to the chilled water. Then chilled water heat load is transferred to the cooling water. That cooling water is there. It is getting cooled from by ambient air through cooling tower. So cooling tower is mechanical, means induced draft cooling tower is there. But here it is for the old chiller, we can see that there is an unequal water distribution. It is not like a normal cooling tower where continuous water distribution in a distributed manner. It should be spread across the cooling tower so that temperature of environmental cooling effect can be achieved in this cooling tower. So this was the another area. Scaling was the first area. Cooling tower unequal water distribution was another area, maybe due to nozzle choking and all this. So these are all regular maintenance issues. So maintenance practices can also be identified based on this, and how maintenance inappropriate maintenance can affect the performance of the equipment, and we are losing somewhere that can be evaluated or can be seen from this case study. So at present, temperature difference in cooling tower was less. It should be around 7 to 8 degrees centigrade, or at least 7 degrees centigrade, but it is less because heat transfer across the cooling tower is not happening due to unequal water distribution. So replacing of the fields with new one to get the better temperature difference across cooling tower, so that further cooling of temperature water can be done, and better condenser performance can be achieved, and ultimately chiller power consumption will get affected. So this is the main area where we are focusing. So this case study specifically taken for buildings, because normally most of the commercial buildings, even nowadays in metro cities or normal cities, consumers all buildings or in houses also, the major power consumption is being done. At least 60% power consumption is done by chilling load, air conditioning load. So another area, like one is we had seen the chilled water side, condenser tube choking. On cooling water side, cooling tower, improper performance of cooling tower or condenser tube choking. Similarly, in case of AHUs, we have to ensure that performance of AHU is maintained. Temperature feedback is given to the AHU operation. Also, the ducting through which chilled air is going, it is properly insulated. There should not be any air leakages or air ingress across this ducting area. So more will heat loss or air loss occurring in this process. There will be more heat load on the chiller compressor. Ultimately, whatever cooling is happening in the room or outside the room due to leakages is supplied by our chiller compressor, for which we are paying electricity bills. So here we had made a thermography. So cold thermography is there. So cold areas were identified where insulation or damage was observed. So in this, HU ducts are under direct sunlight. So we had also seen that the suppliers are saying that these are designed for high sunlight area and all this. But wherever possible, you provide green cover, or of course, it is a matter of architect and other speakers who are going to speak in this area. But there are some possible methods at locally through which you can stop heat coming from outside. So there can be anything, but we have seen some green covers are done, or some trees are grown. So there can be anything that there, it is not written in books. So ultimately we have to optimize the heat load on the air conditioning system, whether it may be from inside or it may be from outside. So these are the possibilities were observed in AHU as well. So ultimately, once you do from cooling tower side, you do from AHU side and chiller side, ultimately the saving is going to come on your compressor side or chiller compressor side. So there can be anything for based on the size of the equipment and building size. Similarly, in case of variable load where you are supplying to unoccupied, sometimes in location your building or your warehouses are partially occupied or unoccupied. Based on that, you have some arrangement through wall. In this case, cooling water pump is supplying at cooling tower at the top of the building, and again that cold water is coming, giving its cooling effect to various condensers and heat exchangers and stored in the storage tank. Now this cooling water pump is operating, this valve or discharge valve of this pump is operating as per the level of this storage tank. So in this case we are suggested to install variable frequency drive, and that feedback can be taken from this level instead of this valve. So these kind of simple possibilities can also be identified in case of AHU fans, city fans, cooling water pumps everywhere. So based on the actual requirement or variation in the system, we can find or install VFD as in our equipments. So this is the case where 25% was the variation in flow. So we have suggested this. So huge saving, less than a year will be the payback period in this case also. Another area where it is a well-known area now, people are maintaining this, but this is the case of one building in Maharashtra where billing is KVAR is also being charged. So here they were having a capacitor banks, but some were not in operation, though they were operating 0.9866 power factor. It is a very good power factor, but further improvement is still possible unless you are reaching at 0.999 in the current scenario. So we suggested to maintain these capacitor banks, replace some capacitors. So improvement in power factor or requirement of capacitors was suggested based on the formula. So a PFC can give you up to 0.99 power factor. So this was the ultimately KVH were being charged, so there were a huge amount of saving was possible in that case. So always maintain the power quality and power factor also, so that you may not get any extra charge from your discom. So these are the advantages. Of course, distribution losses, reduced demand charges, better voltage level, and losses in the power system. Ultimately, the carbon footprint can be optimized. Another area where B is now silence actually. Earlier in the 2009-10, they had started focusing on buildings also, but now due to PET scheme, buildings have come in the PET scheme also. So this policy or this scheme is not in limelight now. People know about ECBC or lead rating and all this, but Bureau of Energy Efficiency had also made some guidelines about star rating of buildings. Like if a building is more than 50% condition, then they are given some EPI. kilowatt hour per square meter per year. So what is the energy consumption per square meter of a carpet area? Similar, based on that, they are given some star rating. So this is helpful for making a benchmarking that individual building, what is their current level, and what is the possibility of improvement. So this can be helpful to you for benchmarking what is your API, and what is the further possibility of improvement in your building. So mainly now lighting side, another area where buildings are making consumption, but lighting, of course, now LED is well known to all. So I'm not taking that kind of case study, but refrigeration or air conditioning system, whatever may be the advanced building may be, but there is always a possibility of improvement in your air conditioning system. So that should always be focused to start your journey towards net zero. So that's from my side. If you have any query, you can write in the chat box. Thank you.
Thank you so much for that insightful presentation, Mr. Vesni. Can I request you to stop sharing your screen once? Thank you, sir. May I now request my team to play the commercial video for Sunshine Energy?
The renewable energy revolution has begun. Conventional sources of energy are proving too costly for the planet. As a renewable energy hotspot, India has the potential to lead the world's decarbonization journey. That's where we come in. Sunshore is India's fastest growing renewable energy company. We believe in delivering maximum impact by harnessing the power of RE technologies to supply round-the-clock clean energy to industries across the country. We run both intrastate and interstate plants to deliver green power at any scale of requirement. Since 2014, we have helped over 60 corporations transition to clean power, cut costs, and achieve their ESG and RE100 goals. Our investors, Partners Group, are powering Sunshore's vision of becoming one of the largest global renewable energy producers. India's renewable energy moment has arrived. Be a part of it.
Thank you, team, for playing that video. May I now introduce Mr. Akash Singh from Sunshore to present for his company. Over to you, Mr. Singh.
Hi, Sakshi. Thanks for that. And a very good afternoon to all of our attendees present here today. So, I'm just going to take you on a brief journey about Sunshore and what do we offer. Just give me a second to pull up the presentation. Yes, let me know if you can see my screen. Perfect. So, I'll just start with a brief introduction of our company. So, Sunshore has been in the RE space for about 8 years now. And over these 8 years, we've delivered about 400 megawatts of operational solar capacity in India, serving over 60 plus customers. Now, we are a unique organization in the CNI space, CNI decarbonization space, in the terms that our sole focus right from our inception has been to cater to the CNI segment. Like a lot of players are focusing on the utility segment as well. Utility segment as their mainstay. Our DNA has evolved through an incessant focus on CNI space, wherein the power demand for each and every customer is different, and we provide customized solutions to all of them. Today, we are the most capitalized company in the in the CNI RE space with Partners Group, who are our global, a leading global infrastructure investor. They put about $400 million worth of equity in Sunshore, and Sunshore will be the sole vertical through which they will drive RE across India. We're also a full stack independent power producer in terms that we do all the EPC work, the lightning work, the government approvals, and everything in house in order to deliver the maximum value to our customers. Currently, we have a pipeline of about 1.75 gigawatts under development, and we'll take you to the remaining slides. Partners Group, like I mentioned, they're the world's leading infrastructure investors, and have infused about $400 million in Sunshore for the CNI space. We provide, apart from regular solar and wind power, we provide hybrid and RTC power PPAs for large industrial customers. We also provide green attributes. For example, in case you need to purchase power from the grid, you can purchase RECs that will help you offset your RE100, offset your carbon emissions towards your RE100 goals. Also, we help companies structure themselves in order to be able to use virtual PPAs. So what we see is, in case the organizations are not able to draw power because of their distributed load or whatever else reasons, so you can engage in virtual PPAs to offset your carbon emissions. We've worked with almost all of the big players in India who focused on decarbonization and net zero. Dalmia Group, one of the biggest cement players in India. Dabur, Kajaria, Sandoz, one of the biggest pharmaceutical companies. Hindware, PG Alpha. Now, specifically focusing on rooftop, we've done projects for Coca-Cola, we've done projects for Kellogg's, across various sizes. For example, a 6 megawatt, which is then upgraded to 9.8 megawatt project for Hindware, which is at that point in time one of India's largest projects, and a bunch of other people. This is a snapshot of our current portfolio. We're doing about 1.75 gigawatt of energy as we speak, and the most dominant player today in the CNI space in Uttar Pradesh. We're building up our Maharashtra pipeline with about 250 megawatts under construction, and we're currently signing PPAs for both Uttar Pradesh and Maharashtra. For ISTS projects, we have about 900 megawatt identified in Rajasthan, with land acquisition already completed for about 400 plus acres, and are developing wind and hybrid sites in Karnataka and Tamil Nadu. So that's just a bit about Sunshore. Now, when we focus on the buildings and warehouse industry, so looking at the emission scenario globally, they contribute about 17.5% of emissions. In India, this number is higher. In India, this number is close to about 30%, as Bhavesh ji had mentioned. And they contribute to approximately 5% of India's national emissions. This is a sector where we need to have intense focus on as we go forward, because it's going to be one of the largest growing sectors over the next 20 years. As on today, we're building about 3 lakh square feet of commercial floor space every day across countries. As urbanization increases in India, commercial spaces, buildings, warehouses, all of them, will be the infrastructure backbone on which the India will grow. Now, everybody is talking about decarbonization, but when we look at segmenting the different drivers of decarbonization, especially for buildings and warehouses, uh, uh, we feel that there are three main drivers. One is the demand side drivers. For most of the urban spaces, when we talk about commercial spaces and warehouses, people are focusing on the need to select commercial spaces and warehouses based on their emissions portfolio, because most of my customers are looking to lower the both scope 1 and 3 emissions. Policy framework and supply side drivers, Bhavesh ji has touched upon this a little bit. New buildings have mandated energy efficiency regulations and compliances. There are some schemes, for example, in Haryana, according to the Haryana Building Code, the Griha scheme, which is basically the BEE star rating. So if your building is a BEE 5-star rating, you can get up to 15% additional FAR for the same size of plot that you have compared to a building which does not have a BEE Griha rating. Higher ESG ratings also allow you to access lower cost financing, wherein we've seen our customers experience roughly about 2% lower cost of financing just because of the higher ESG score. On the cost side, definitely the cost of RE is always going to be lower, especially because buildings and warehouses typically come under the commercial tariffs, which are probably the highest in the nation, somewhere touching around 12 to 15 rupees in some states. Also, efficiency improvements, which are a driver for decarbonization. There are also lower operational cost and challenges. Commercial spaces are typically leased out, so that's the ideal scenario in terms of operational hassles that the developer or the building operator avoids. Now, when I talk about load, the electrical load in a building, so as Bhavesh ji had also mentioned, the typical HVAC or the air conditioning load is about 35%, and this is for a tropical country like India. Globally, this is slightly lower because the temperatures probably do not go as high, and much of HVAC relies on heating as well. But in India, I think air conditioning is the way to go. 20% is the common area load, and about 45% of a building's typical load is the occupancy load. That is the people who lease out their electricity use, their computers, electrical equipment, and the rest of the stuff. Now, as you guys and some of the other speakers will probably know better, and will give you a much more in-depth view on what are the steps that we can take to abate these emissions. Uh, what we see is buildings have typically one form of carbon emissions, which is through electricity consumption. Now, HVAC being the prime driver, for new buildings constructs, HVAC load can be reduced in two manners. One is you reduce the glass frontage or the facade by introducing more brickwork so that solar radiation doesn't come in and heat up the space. So that reduces your need for air conditioning. And the second way is by using technology such as double glazing and something that you guys call lower E glass, which reduces my heating inside the building, lowering the HVAC load. There have been multiple advances in HVAC technology with variable VFDs and variable air volumes on the blower sides, which lower the demand. Also, new technologies are being tried out across the world. For example, Sheikh Zayed Road in Dubai has something innovative in terms of cooling called a district cooling system, wherein the chillers and the AHUs, they are built on a larger scale and cater to multiple buildings, so that through ducted airflow. Now, this reduces my overall capex cost, as well as overall capex cost, as well as my distributed load factor. So basically, that's something that the real estate industry uses in order to calculate the overall heating or the cooling load. Now, district cooling is being implemented in India. It's not found great success yet. But for example, Gift City in Gujarat has provisions for district cooling. Some developers in the NCR region are also going towards district cooling. For example, in some of the developments in Aerocity, we've seen that they've opted for district cooling, which definitely is a big driver in terms of both OPEX and CAPEX cost reductions. There have been multiple schemes such as a LEED, IGBC rating, and the BEE rating scale, through which buildings are compared in terms of their energy efficiency. And this efficiency again is a driver of big driver of demand. Now, in terms of regulation, so nowadays, at least for Delhi NCR, about a 5%, at least a minimum of 5%, and going up to 20% of the building's demand has to be met by rooftop solar or on-site solar. So that's become a key factor for Delhi NCR, and going forward will be a major factor in consideration as more and more areas urbanize, and even some of the other metropolitan areas adopt stricter emissions norms. Also, on the same vein, diesel generators are nowadays being phased out in Delhi NCR. People are being asked to put on dual fuel or gas kits on their existing diesel generators. So, the government is taking a lot of steps on the policy front also to encourage, carbon emission reduction. Excuse me. One new concept that we've, recently seen is the introduction of electric vehicles and the mandated EV charging base, which is a major driver of demand in almost all of the new build construction that we're seeing. With most recently almost 20% of the parking areas in commercial buildings to be powered, to be ready for EV charging. With that kind of requirement, I think the load on the buildings substantially increases, especially given the older set of buildings that have already been constructed and in land. That will not be a concern in areas where there is no dearth of land. But for example, in places like Bombay and Delhi, with these kind of mandates coming in, the load on the electrical infrastructure is becoming a very difficult problem to manage. Now, this is where Sunshore comes in, wherein we can help you with all forms of power. We can help you with on-site power, which is your direct rooftop power, which can power up to about 15% of your energy consumption. The remaining 60% can be powered through open access PPAs, wherein the plant is set up at a remote location, and through a bilateral contract, energy is sold to you through the RE developer. And the remaining 25% of emissions can be offset through green attributes, which is basically supply of carbon credits and the carbon emissions trading scheme, which will be operationalized in the country by, I hope, end of next year. Open access power gives you about fixed power tariffs for about 15-25 years, depending on the duration of the PPA. This is extremely important for the building sector, because commercial tariffs are today highest across the board, across all states in India. There is promotional government policies and waivers. There is no cross-subsidy surcharge, additional surcharge on captive open access. We can replace approximately 75% of your power through green electricity. And, there's absolutely no exposure to risk in project development, technology, or operations, because we'll be doing that for you guys. This is how a typical solar open access works, with a private plant located, somewhere in high radiation and high resource rich areas, powering a remote, transmitting power to a remote substation, which through the transmission and distribution network reaches the final point of consumption, which is the building. Now, this is an illustrative unit economics for open access RE, This is for industrial HT consumers, which typically pay around 9 rupees 35 in Maharashtra. For commercial, I think this tariff is around 12 rupees today. So this 37% savings straight away translates into over 60% in electricity cost savings, or about from 12 rupees to about 6 rupees is straight away half the reduction in cost. This is the typical life cycle for open access and RE power. We The phase one is development, which has already been completed for about 50 megawatts of projects in UP, 150 megawatts in Maharashtra. And phase two is customer onboarding, and third phase is project delivery. So for from basically PPA signing to power delivery can be as quick as 6 months, or even quicker in some cases where construction is already underway for our projects in Maharashtra and UP. The best structure that we have seen is captive structuring in such cases, wherein the customer puts in 26% of the equity. That is just to ensure regulatory compliance, and all of the work and the operations will be handled by Sunshore. This will help you in saving some aspects of your charges, and that's basically how the open access structure works. Now, for places such as warehouses, behind the meter rooftop installations are the way to go, because probably with newer warehouse builds, that's very easy to integrate. This is something that we had done for Hindware, which starting out at about 6 megawatt ended up with a final capacity of 9.8 megawatt. At the point that this was completed, it was the largest rooftop installation in India. We've also done similar projects for Coca-Cola and Merino. So basically for warehouse, I think bulk of the power demand can be offset through rooftop solar. This is also enhanced by the states which offer banking, wherein when you generate energy during solar hours, that same energy can be redeemed from the grid in non solar hours. So that allows you to offset a higher percentage of your consumption. Some of the open access ground mounted projects that we've done is for about Dalmia Cement for 17 megawatt. Dalmia Cement, another one. We have about 15 megawatts of two projects of 15 megawatts already operational in UP, through which we're supplying power through open access. And this is just a snapshot. These are my coordinates. You can reach out to me in case you have any requirements. Also, I'll be dropping my email ID and contact details in the chat in case we can connect further. Thanks a lot for this. This is all from my side.
Thank you so much, Mr. Singh, for that insightful presentation of yours. Uh,
Thanks, Sakshi.
as we all know, net zero buildings are globally acknowledged as one of the loftiest goals in energy performance within the built environment. As of 2022, the building sector is responsible for approximately a third of total energy system emissions. This includes emissions from buildings operations and embodied emissions which are associated with the production of materials used in their construction. India, the second most populous country globally, has witnessed a substantial surge in the demand for buildings. An estimated 70% of the buildings projected to exist in India by 2030 are yet to be constructed. Despite this, India has made noteworthy commitments to sustainability, exemplified by its ambitious goal of achieving net zero emissions by 2070. In our webinar today, the aim is to address concerns and challenges associated with the push for net zero energy buildings and green construction, thereby paving the way towards a more sustainable future. Before we proceed, I would like to make a brief announcement. We encourage all attendees to actively engage in the discussion by posting their questions in the Q&A box. Our esteemed panel will take up these questions once we conclude with the panel discussion. Now, without any further ado, let us begin our highly anticipated panel discussion session for today. It is my pleasure to introduce our esteemed panel of experts who will share their insights and expertise on the topic at hand. We have Mr. Yatin Chaudhary, who will be co moderating the session. He's from Terry. We have Dr. Mala Singh from CSO Global, Dr. Sunita from Mahindra Lifespace, Ms. Sultana from Facade Engineering Consultants, Mr. Akash Singh from Sunshore, Mr. Najid, Mr. Najid from who's the director at EY Climate Change and Sustainability, Mr. Panigrahi from DP World, Mr. Vaid from Flipkart. This session will be co-moderated by Mr. Sharif and Mr. Yatin. So I will just hand over the mic to Mr. Chaudhary and Mr. Kumar now. Over to you.
Thank you, Shakshi, and good afternoon, everyone. And uh, I welcome you all again to this discussion where net zero energy roadmap, building and warehouse, where we are discussing the paving pathways for decarbonization and initiatives for energy transition. Uh, what I would like to thank is our earlier presenters and Shakshi, all of them, for setting up the context. One thing which Shakshi mentioned that India has set up a very ambitious target of having net zero emissions by 2070, and in achieving so, buildings are going to both residential, commercial, and warehouses are going to play a very important role, uh, both in terms of operational energy as well as embodied energy. So, in order to proceed with this discussion, we have a very esteemed set of expert panels which represent sustainability professionals, ESG experts, research organization, supporting industries, corporates, and developers. And we would like to hear from them their views on current trends in the industry, what technologies, policies, and corporate social responsibilities are there. One thing which I would like to request to all of them is to look at the social economic diversity which we are having in India. And though ECBC and Econivas Samhita like codes are there, there are certain limitations in terms of at what level those will set in. For example, 100 kilowatt and above, the ECBC codes are implemented. And in case of ENS, which is Econivas Samhita, only the plots which are beyond 500 square meters will be applicable. But in order to achieve this net zero energy goal, net zero emission goal for 2070, we need to have a holistic view. And with this, I will request our first expert, Dr. Mala Singh. Uh, she is a founder and managing director of PEC in Greening India, and at present also board of director of CSO Global USA. Dr. Mala Singh has been providing solutions for sustainability, climate strategies, ESG, net zero, and green building for multiple sectors for different organizations. Uh, Welcome, Dr. Mala. If you can,
Thank you.
yeah.
Thank you, Yatin. Thank you so much.
Yeah, so in terms of this net zero energy buildings, specifically for buildings, what are the existing and more importantly, emerging policies which you see are related to emission reductions and how they stand compared to net zero goals? If you can share your opinion on that. You have
Yeah,
approximately
yeah, yeah.
5 to 6 minutes
Oh,
for this
okay.
particular question.
Even I would love to be with time constraint because my previous speakers have already spoken about a lot of policy interventions when we talk about emission policies of India. Like somebody speak about PAT scheme, and then I think previous speaker has already talked about a lot energy conservation codes and all that. So I think one thing which I feel that was missing link, I think I want to just cover up that in this discussions, because being a sustainability and a net zero professional, so I feel that in India, if you look into the policies, we don't have such as a mandate mandate of policy like it is mandatory to become net zero building or something like that. It is more voluntary basis, because uh, like same phenomena is in the green building sector also, because people are talking now net zero, but I think it has a lot of synergy with the green buildings, because green buildings defines our fundamental principle of your energy optimization processes through design interventions, through, I would say, through passive approach, through active approach. I think one of the speaker has already talked a lot of stuff about case studies, which was totally based on the active approach he talked about. So he talked about his operational efficiency, how could you reduce, and what kind of measures, auditing mechanisms we could use you to bring down your energy loads. So he has already spoken about that. And second, I think just to use the alternative sources of energy, the second speaker has given a lot of insight about use of your green energy applications in the building and warehouse sector. So that may be on site, that may be off site. So coming to the passive approach, I feel that which is the most important component and generally we ignore. Because in India, when we are talking about this net zero roadmap, so we always feel that being a India, we are per capita, we are on the very lowest rank. But when we see ourselves as a cumulative, in the portfolio of statistics of carbon emissions, so we are the third number. I think most of you know that fact already. So I think from that perspective, it's very important for us also to look into this energy roadmap from very holistic perspective, like it's a pyramid, okay? So the in the pyramid game, first is energy conservation through a passive approach. So how do we look into the design interventions where we could reduce your energy consumption, your demand loads by designing our building in such a way so that your lighting loads are less, your air conditioning loads are less. So how do you look into the design interventions who are more prone to the climatology? Those are more, I would say, human, I would say intervention as its regional priorities, its climatic priorities. I think that we need to always address to achieve the passive design goal. So once I think we look into the passive design approach, so at least we are starting from the first fundamental principle when we talk about the conservation. Then I think second step in the pyramid, which is energy efficiency. I think a lot of stuff has been already talked about by the previous speakers, where he spoke about your, a lot of stuff about mechanical equipments. How could you look into the efficiency part by applying ECBC codes, by looking into the PAT scheme interventions. So I think, and the third is the last, which is an alternative source of energy, which is a green energy. And I think in Indian context, when we talk about the commercial buildings or warehouse building, the difference in this alternative use of energy application is, I feel that you have large roof area available in the warehouses. So you could have the opportunity to use your rooftops for setting your solar plants there. Even you can generate, more energy and you can give it to the grid also. So that is an opportunity always in the warehouse buildings. But when it comes to the commercial buildings and high-rise buildings, there definitely we have a constraint, because you have a very small space of roof and where you have utilities and other equipment also. So I think there our off-site green power, the policy interventions really works. So either we can look into the open access policy, or we can purchase the green power. And this is what actually happening in the market, and a lot of case studies where the most of the corporates who have the policies and their ESG commitments to fulfill their goals and objectives of net zero, under that portfolio of ESG commitment, they are definitely, following these sort of strategies. because they know that what could be generated through their facilities and what they can buy as a green power through various policy interventions. So that thing is already very much in, and people are already doing, the corporates are doing it under their CSR activity also. So apart from that, I think if you look into the net zero transition, to become net zero, I would say one is your cutting down your emissions through energy gaps and fulfilling those gaps through alternative methods. Other is the biodiversity also, which we generally ignore, so that is also very important to look into. So how we could enhance, biodiversity, can plant more trees, and can look into the decarbonization process through plantation and through maintenance those forest areas, or adopting some, green spaces, planting more trees. I think that has also a lot of significance in this current scenario, which generally we ignore. Why I'm saying this, Yatin? Because if you look into the emission scenario in India itself, so our 37% carbon emission is from the power sector, and then, after that, industrial sector, and after that, we have agriculture sector, which is also very important, apart from transportation sector. So in agriculture sector, generally I have seen that that's the most important area, because of the, it's not carbon dioxide emission because of that, but because of the methane gas. Because we have, various aspects and various thought process where now we need to intervene from the policy point of view, and we need to address those challenges also, and we need to look into the mitigation measures also. Because if you see the agriculture industry, due to economical condition of the farmers, they are not so equipped for the technologies or investments.
So no,
So
we
there I think these are the areas.
will feel specific to buildings. I understand the point which you have made regarding the pyramid approach and addressing the larger strata of socioeconomic group with the passive measures and supporting other
Yes.
technologies. So thank you very much for your comments on that. Now I'll request Dr. Sunita Purushottam. She's head of sustainability at Mahindra Life Spaces Developers Limited, and she's a very driven and enthusiastic person, and very result oriented, and having demonstrated track record of experience in a lot of national and international projects. She has also been associated with Terry. We have Center of Excellence, Mahindra Terry Center of Excellence. So I would like to request Dr. Sunita Purushottam regarding, as Dr. Mala Singh was mentioning, that corporate social responsibility. Mahindra Life Spaces has been at the forefront of implementing sustainability in their projects. And we would like to know from you what are the current trends in terms of technological innovations which are being implemented in the industry, which contributing to net zero energy buildings, including both operational energy as well as embodied energy, some aspects which are being done in Mahindra Life Spaces. Over to you, Dr. Sunita.
Thank you. Thank you so much. And a great platform for myself also to learn from other speakers. And I will definitely, I'm connected to Dr. Mala Singh anyways, but I would love to get connected with Akash and follow up on what follow up on what he has just shared with us. So a wonderful platform for learning, I would say. So thanks for this opportunity. I will, I don't like the word technology. Uh, and though I have been associated with, I've been with Infosys in my past. The reason why I abstain from the word technology is that it makes it inaccessible. It makes it feel that it is something which we cannot do, or it makes us feel that maybe we are not knowledgeable enough to get to net zero. For that matter, if you use the word technology, it actually drives many normal human beings away from the concept itself. So it makes it feel that maybe it's costlier, maybe you will have to do something, maybe it's equipment, or maybe it's a maybe it's something. So it's either it's an engineering technology, or it is a information technology, and that makes it kind of inaccessible. So what I definitely want to do is to say what we are doing, okay, uh, and it is not technology, it is something which is very common sense, and we want sustainability to be accessible for all. And we have 100% green portfolio, and believe me, it is tough to deploy 100% green portfolio. So every home that we sell will have a certification, and we have been front runners since 2014. Our entire portfolio since 2014, we are committed to a complete green portfolio. So what are the solutions? The word is solutions instead of technology that we deploy. So the approach to moving towards net zero is quite holistic. It involves various areas of energy, water, waste, materials, indoor air quality, biodiversity. So it's pretty holistic in terms, and it starts with a process called as integration. We use an integrated approach to design. So right from site selection to whether what would be the flow of water. So the building the climate resilience. So what would be the water stress, where would water come from, what would happen if more water comes in, what would be the impact on the built environment, and how does the building itself impact water, biodiversity, the site conditions, and so on. So it starts there. So we are involved in the site selection process and give our views on what needs to be done. Then we go with the designing of the building. So this includes the green spaces, how we orient the building, and this is where the entire climate responsive design piece comes into the play. And this is common sense, because we, as in India, we are known for great indigenous architecture, and which takes into consideration the sun path, the wind, and so on. So that's passive design, basically using elements of orient, avoid, orient, reflect, shade, and that's important. Shading is very, very important. And if you shade properly, and you do you really don't even have to invest in glass. Then the wall to window ratio, so we are believers in smaller window openings, and Akash alluded to that, because windows in India never used to be big, and we are not in favor of too much glass, though we get a continuous internal pressure from our marketing teams that customers want more glass, and we have to explain to them that customers don't know what they are getting into, right? So we have brought in foreign concepts of end-to-end glass buildings, but nevertheless, when you start staying in those homes, we feel a lot of discomfort. So getting to a parameter called degree discomfort hours, visual comfort, we have also found out from the Mahindra Terry Center of Excellence Research, where we have set up sky scanners. So what does the sky scanner do? It actually is a equipment that scans the conditions of the sky. So we've set one in Gurgaon and set one up in Chennai, and we have found that the sky conditions in India provide enough light, daylight, even with small window sizes. So we don't have to, and basically all the models that we use to simulate daylight are under cloudy sky conditions for European countries. So that's the data we use to show daylighting. Actually, the data, we don't have Indian data. So we are collecting Indian sky condition data. And that actually strengthens our premise that we don't need big windows. And it's a big fight, actually, the size of the windows and the wall assembly. So there is another element of the U value of the walls. What should be the thermal transmittance of heat through the walling assemblies? And concrete is a has a very high U value, which means that more heat will be there locked in into your spaces. So the first element that we look at is the climate responsive design. the building assembly, and that's a critical portion of how you should design homes. Then we look at the construction practices, then how should we do the handover, the entire procurement process. So it's a end-to-end integration. So I would wrap by saying that more than technology, it is the integrated design approach and use of knowledge that we had to do better design, and therefore save energy on that, then go to energy efficiency, then integrate renewable energy, which is 5% on site, which Akash also alluded to, and then grid integration.
Thank you, Dr. Sunita, for that insights. As Dr. Sunita has mentioned, that envelope, thermal transmittance, and other things play a very important role in efficiency of a building. Our next expert is Miss Ashika Sultana. She is a senior consultant of sustainability in Wintech, facade engineering consultants. She's a green building consultant specialized in sustainable architecture, and has experience of climate responsive and energy efficient building design. I'll request Ms. Ashika Sultana to elaborate on the importance of fabric in achieving net zero in buildings. Sorry, we have recently come across a report by IEA that out of all different things, probably envelope is the most ignored feature throughout the world. What are the reasons for that, and how the industry is responding to the facade related aspects while designing a building? Over to you, Ms. Ashika.
Thank you for so much, Yatin sir, for inviting me to the speech. And first of all, when the program was scheduled, Geeta ma'am was approached me about this topic, like, can you speak about the facade aspects? And I was so excited about it. And it's indeed important. So I would like to add a few points since where Sunita ma'am has spoke about, because the importance of an envelope, or what we call facade design in building construction, is underestimated most of the times. Yes, uh, we consider envelope as a first level of protection from the external environment, but it also plays a crucial role when thinking about the overall energy performance, or the overall occupant comfort of the structure. So it's a good sign that people are started realizing it and they are working on it, instead of thinking about what the industry asks for the benchmark. So it's so promising. And also, when we speak about achieving net zero, we know about the targets, like we have to limit the global warming in 1.5-degree limit as per the Paris proof. When the industry find out these kind of targets and set a net zero, we also have to think about, are we going to achieve this net zero, especially in Indian context, based on uh, achieving operational efficiency, or going forward with the overall whole life net zero goals. And in the first presentations our speakers were going forward, we could get to know better about the operational reduction. And another important aspect is embodied reduction, or when you think about the whole life carbon, and the facade plays a lot more importance to it, because it says that almost 17 to 25% of the total embodied carbon share of the building is generally into the facade design and facade implementation. So it has a significant share in both reducing embodied carbon and operational carbon. And if you say in terms of a new building, we even named it as a fabric first approach, because often contributing to our passive architecture means in the architectural design, architectural spatial design, then we may think, okay, if you add a few shading devices, our facade design is complete. So it's a wrong consumption, because we are knowledgeable about the daylight ingress. At the same time, we have to think about the amount of heat gain through that building, and ventilation and the air quality is another aspect we are declining when you think about the facade design. So if you have a well insulated envelope, which is having the material which are apt for that particular uh, climate climate of the location, then half of the problem would be solved. And another aspect is achieving net zero while going forward with the existing buildings in the portfolio, especially if you are thinking about aiming net zero carbon for an organization. And our first speaker has also spoke about the scope 1 and scope 3 emissions share when building industry is trying to decarbonize. And let me tell you, the facade has another important part on this. Uh, because if we don't build anything, that's the most sustainable solution, but we cannot do that. We have to build. So if we repurpose a building or retrofit a building, there would be again the fabric first approach would be most adoptable, because it prioritizes the improvements in various stages, and it also ensures that the existing building fabric has to have certain amount of energy implication. So you are finding that through an audit first. And this approach is important when taking decisions for major improvement, because mostly it may not be energy efficiency associated. There can be other intrinsic benefit. Say, for example, there can be the structural aspects of the building, or it can be the condensation issues, or it can be the movement risk. So sometimes there is a high capital cost for the facade improvement on other aspects compared to the energy aspects. So if you have another goal of improving the facade, then it's equally important for you to consider energy efficiency or being net zero at this point. So when these projects go ahead for other reasons, such as maybe deterioration of existing fabric, especially if it's a industrial building, because most of the times the process will give importance, and the energy consumption of the project process may give the emphasis, but the structure where the process happens also has to be thought about. And so it shows an opportunity to significantly improve your overall carbon portfolio. So it may be simple techniques like improving the insulation levels, for example. It reduces heat loss or heat gain and improves energy efficiency. So it reduces the capacity of the cost investment has to be equally thought about, uh, the the operational savings or the embodied carbon savings, and then we have to go for a solution. So mostly, if you change the heating system, it would be having a shorter lifespan than if you are changing the structure of the building. So we consider the lifespan of the building as somewhat up to 30 plus years, and the service life of the other components may be even more. It can be 40 or it can be 50. But if you think about upgradation of system, M&E system, the service life may be 15. So I think when you think about upgrading a facade, you would also have to think about the overall life cycle aspects. And especially if you have a whole life carbon goal with giving equal emphasis on operational carbon and embodied carbon, then your take should be the facade first approach. And I think Yatin sir was asking the second part of the question, like if how the industry is responding. It's not so promising, but still, if you compare, India has to grow a lot, and Malama was discussing about the per capita usage. Yes, right, we are consuming less, Uh, but if you think about the quantum of what we have as a whole, we may have more strict and stringent regulations, because there is a tendency for everyone to follow if something is uh, opted or implemented as a rule or regulation, rather than taking a voluntary step towards that. So I feel that India needs to have more stringent rules. Yes, there is energy conservation building code. It gives emphasis to envelope. The first section of the building code is envelope right now. It talks about the U values. It
Yeah.
talks about the leakage. But apart from that, we don't have any targets and benchmarks like this particular building has to limit within this range compared to the developing countries. So that would be something that I'm looking forward as a
Yeah.
person who is working in India and both in other developed countries. So that may be one reason they are able to stick to us their goal and achieve more result
Thank
compared
you.
to country.
Thank you.
Thank you.
Thank you, Ms. Ashika. As you were mentioning, to have a stricter regulation would probably be a way forward. Uh, in current regulation of ECBC, there is a provision of providing space for future renewable energy integration on rooftop. Is it is there, and as probably you all will know that because of this Energy Conservation Amendment Act, which happened last year, they are going to include sustainability and more rigorous financial mechanism also for implementing credits for emissions and other things. So our next speaker, Mr. Najid Narmawala, I would like to invite him. He's a director at Ernst& Young Climate Change and Sustainability. He's an expert, experienced professional with demonstrated history working in infrastructure, climate change, and sustainability sector. He has been into policy advocacy and provided inputs for vision mission statements for government agencies. I would like to ask you, Mr. Najid, regarding since our emissions from building sector, which presently is in range of around 40%, and by 2030 is about to increase to around 50% because of the increase in building footprint. Uh, what do you think that whether our current policies are converging uh, to the targets which are there, 2070 net zero energy emissions target? If not, what are the expected kind of revisions in policies do you think should be there for whether it is mandating renewable energy or net zero energy buildings of certain size or things like that? What is your opinion on that?
Sure, Yatin. Thank you so much, firstly, for organizing this webinar. This is an excellent opportunity for all of us to connect and exchange our ideas and thoughts. We all have been in different sectors and also implement ESG and sustainability in different aspects. I have my own point of view and also have developed this point of view working in this field for more than 12 years now. Worked with various sector clients and in various regions. um, as you rightly pointed out, Yatin, that yes, there is a lacuna in terms of the policy setup, which is there as of now with the existing regulations in place. However, our government is coping up to that particular lacuna in various ways. My point of view is that they want to make BRSR as the center stage of everything that they want to regulate. Firstly, the government eyes to set stricter regulations on disclosures. Once the disclosures are in place, they would want to use that disclosed information in public domain and run their statistics and models to be able to understand the different policy regulations that they can bring in. For example, the carbon tax which is being implemented in other countries, not necessarily in the same form will be applicable or should be implemented in India. Those statistical analysis, those analysis will be will be will be possible because of this baseline information which is getting collected from BRSR reporting. BRSR is now also being seen from to drive value chain perspectives. The government does not want to directly get in touch and implement sustainability initiatives at MSMEs and small cottage industries. However, these industries are always associated with the large corporates who are the top 1,000 listed corporates, and in a way want to drive sustainability through them. So they have come up with a BRSR core mandate, which requires the companies to work with their value chain partners and report on behalf of them the sustainability BRSR core information in their annual report. However, this is not the only thing. There are various other interventions that I would want to point out, not trying to repeat what has already been discussed. Various schemes and initiatives have already been discussed. There's one thing that I would want to bring to your notice. In fact, two things. One is on the solar policies, the which are getting updated, and also the new open access flexibility that have been provided will give a lot of boost for companies who are very much interested in adopting to renewable energy and being able to procure energy without any restrictions. Yes, up till now, companies who even wanted to go for more and more renewable power were restricted because of several rules and regulations, which with time the government will work towards having the right balance between renewable and non-renewable. It is also an important aspect from power factor point of view, so they cannot relax completely. But yes, it will happen from time to time. Secondly, there is also one discussion going on emission trading scheme, which is primarily the way in which the companies would for time being offset their emissions from the companies who have been emitting or avoiding emissions, and their credits can be used as part of a emission trading, which setup is being done by the Indian government, but as of now it is still in the draft stage. Few more such interventions you might see in the in the coming time, but taking the developments and the references which are happening globally, like the EU taxonomy which has been proposed, or the CBAM mechanism which is proposed in EU again, will take center stage at some point in time after understanding the consequences and implementation challenges which they face. As of now, every country is talking about it, but yes, there are very few countries who have been successfully able to implement. But in some time, I definitely see that carbon tax is something that definitely will come up. That's it. I think, Yatin, I don't want to repeat anything that we've discussed. That's my point of view from the new regulations that may come in.
Thank you very much, Mr. Najid. Now I'll move on our focus to more towards warehouse related issues, and I'll request Mr. Alok Panigrahi for he is the deputy manager DP World with over 12 years of experience in consulting and corporate roles. He has been assisting MSMEs and other industries and embarking their sustainability journey. Uh, Mr. Alok, uh, I'll request you to answer on what are the best practices in energy efficient buildings in warehouse designing, and how far we are from net zero energy status as of now, and what should be the approach towards this net zero
Okay. Uh,
warehouses.
thanks, Yatin, for the invite, and it is a great platform indeed, and it is very nice to hear and the expertise views of the speakers. So since we are discussing right now about the warehouse sector, so I would like to say that if you look into the logistics and warehouse, how it has evolved, so it is increasing right now at a CAGR of 12%. So when we see the CAGR of 12% and a basic requirement of almost 500 million square meter of warehousing area by 2025, So it becomes very much imperative for everyone to that how exactly we can come up with a system in terms of warehouses that would be not only smart but even green. So starting with the logistics policies to PM Gati Shakti that you can say right now. So it is very much important that in terms of our design, in terms of our operations, we need to be more sustainable. So just to give a little bit glimpse of how exactly the placing of different warehouse has been done so far, you would be seeing that many of our warehouses has been concentrated at the basically in the very big cities. But right now there is a change in trend. As we are right now, we are talking about how it is going to help us in our net zero imperatives. So we can see that right now the concentration is more moving from tier 1 tier 2 cities to tier 3 cities as well. Right now the absorption ratio, if you look into that, then you can see uh, starting with Delhi to Pune to Mumbai, it is kind of a decreasing trend. But ultimately what is happening is the customers are demanding right how fast their products can reach there. So if you try to look into the warehousing part again, it may be your logistics, it may be your warehouses, it may be the retail warehouses, or maybe your free trade warehouse zone. What is important is how exactly it is placed to the demand centers. So while designing from the designing stage itself, how exactly we can plan in and around how to place our different warehouses so that it can cater the need of the customers. That is something need to be taken into account. And from the construction point of view, I would say that definitely there are few points that was explained by Dr. Sunita and others, that how exactly the sky condition data that has been taken into consideration while designing of the warehouses. So it is very much important that when we look into the warehouses, the basic load is into if you divide that into basic three parts, that is your heating, cooling, and your lighting. So cooling, just like initially it was explained that it was almost 35% of the load demand is going for the cooling purpose. So how exactly you can define a better system in and around to reduce your cooling demand, that is the key right now. So I would like to I would happy to inform you that DP World has recently launched one campaign, that is the join the move to minus 15 degrees Celsius. So I would just like to explain a little bit more about this. So initially, if you look into the past, then way back in 1930, there is a kind of a global consensus that we need to keep our products, that is food products, at minus 18 degrees Celsius. But right now, after a research and multiple kind of collaboration with international institutes of refrigeration, we have finalized that the temperature requirement is not minus 18 degree without impacting the quality of the food. Still, we can maintain the temperature at minus 15 degree, which can have the potential saving of 5 to 7% across the value chain. Even how the Najid was explaining about the BRSR core requirement in terms of the value chain emission requirement, value chain reporting, it has become imperative for organizations that how they can reduce their overall emission footprint. So in terms of warehouse, it is more about how exactly what is your emission per tons of equipment handling, or per tons of container handling, or per tons of load handling. So more efficient warehouse designing in terms of better warehouse management system, automation in terms of barcoding, you can say that RFID integration, use of AI and robotics arm for better inventory management. At the same time, going for green energy. Right now, if you look into the Maharashtra, to be very specific, earlier it used to happen that it is basic requirement was 1000 kilowatt, then only you can go for green PPA. But right now there is an amendment that if you are having less than 100 kilowatt as well, if it falls into the same circle, then you can go for green PPA. At the same time, there is options for companies to go for green tariffs just by paying 0.66 paisa per kilowatt hour. So a lot of regulations are changing, and companies are not just by action but by the intent as well. They are showing interest that how they can absolutely integrate different environmental aspects, not only from the net zero point of view, but even energy point of view, but even from the waste and water perspective as well. So I would just like to highlight only one point before I wrap up. So whenever we are talking about any warehouse or industrial zones, or maybe industrial parks, it is important to understand that rather than a kind of business place, we need to see that from the social cohort point of view. Industrial park is a social cohort plus the green integration. So once these things can be done, I am very much sure that the very idea of getting net zero by 2070 of the Indian government is not so far, and we will achieve that much more before.
Okay. Thank you very much, Mr. Alok, for that positive note. Now I'll request Mr. Akhilesh Vaid. He's the Associate Director of Flipkart. He's a management and sustainability leader with more than 14 years of hands-on experience in managing all aspects of projects life cycle. Uh, Mr. Akhilesh, I'll like to request you to give your insights that given your experience in implementing the solar access on Flipkart group, what are your views on renewable energy implementation and green warehouses? Over to you, Mr. Akhilesh.
Thanks, Yatin, and thanks to India Net Zero for giving me this opportunity. And I think most of the things are being covered by the co-panelist. The beautiful insight has already been given, but however, I will come more from the practical side of it, wherein we have also committed to be net zero, and how do we, as a company, we are embarking on net zero journey. What are the various learnings which we have had over the period of time, given the kind of model built to suit models warehouses we get into. So, everybody has already mentioned that India has already signed up for becoming net zero energy by 2070. So, and then it becomes more so imperative for us to embark on this journey. And I think warehouse as a sector, uh, barring the cold chain warehouses, is a low hanging fruit wherein we can definitely become net zero, given the energy requirements are very less, and if the things are being beautifully designed, we can make up for it. And given the paucity of time, so I would take you through the practical aspects, the key learning on rooftop solar which we have had so far, and we are learning as we are doing, right? So I would also capture some of the policy interventions which we see should happen, which would definitely help industries, corporates to implement rooftop solar primarily 100% and become RE 100. Having said being so one should be very mindful, being a when we are going for a rented facility or a lease facility. At the outset, when we are going for a build to suit model, we should ask from the landlord to provide a green power with EA rights. When I say EA, is environmental attribute. So we have seen in the past, even if we are getting green power, but there are no EA rights, so eventually it becomes a brown power. So you end up spending more to make it by RECs, like Akash mentioned, to make it a green power, so to speak. So one should be very mindful of putting these clauses into play, and then this green power can be done through rooftop solar, green open access, or any other instrument what is deemed suitable for the landlord. However, if let's say if that is not getting covered, he is not willing to provide. So one should also ensure that the roof access rights are being captured in the lease, so that there are various companies like Sunshore we are working with in one of our warehouses. So who are willing to install rooftop solar on on OPEX model, and which makes it very critical, so to speak, that the space underneath the roof. The times have changed now. The space underneath the roof is equally critical as the space above the roof. So earlier we were never bothered about roof ke upar what is happening, but now it has become a very critical element of the warehouse. And then one should also ensure that at the design stage itself, the loads are being captured for to take care of the solar panels, which is indicated tentatively 15 to 20 kgs per square meter. So that's something on the learning side. If some corporates are willing to get into rooftop solars and they are getting into new leases with the landlords, so they should be mindful of this. On the policy intervention, I would say, while there is a huge push or impetus across the globe and also from government of India to become net zero in all aspects, be it water, waste, shifting to 100% RE. Now, particularly speaking of RE, I think there exists a dichotomy among state discoms and private consumers who wants to develop RE renewable solutions at their premises. So, by what does that mean is they consider it's a revenue loss for the states, because power, electricity is again a state subject. And now, when we say so, is why we say so is looking at the various policy constraints, which I would highlight. Like first, I'll speak about net metering and open access only. And Pardon me if my understanding is a little wrong, but then I think this is what we have learned. And obviously, like everybody mentioned, the policies are evolving, and my friend from EY also mentioned that. So net metering is something wherein you are pumping excess power to the grid, right? But different, there is no uniformity across the states. Different states have stipulated different capacity barriers, and some of the states don't have net metering policy itself. Like if I talk about Haryana, they have reduced net metering from 1 megawatt to 500 kilowatt. And like states like Karnataka, which are promoting net metering to the tune of 2 megawatt, Tamil Nadu has a different net billing policy. And when it comes to West Bengal, it's like only 10 kilowatt for residential buildings, so to speak. And I mean, eventually, what does this mean is it limits us to install solar to the tune which we can. So apparently speaking, we can't be 100% solar with only with the rooftop installation. Secondly, there are constraints in terms of contract maximum demand. Let's say you have a 1500 kVA contract maximum demand. Depending on the states, you are being constrained to put 70 to 80% of the solar on the rooftop, which broadly speaking entails to 1000 to 1200 kVA. Now, if you have net metering restrictions, like if I talk about Haryana, like 500 kilowatt power, there if you avail that facility, if you avail that, you can pump the excess to the grid, but then your need is much more than what is being offered by the state, right? So eventually, meaning that you are being if you take this, then you can't extend the rooftop solar. And if you extend the rooftop solar, then the way Akash mentioned, then you have to go behind metering, which means you are definitely not will be able to pump to the grid, right? And second thing is there is still ambiguity. Who gets, when you pump to the grid, who gets the EA rights for that power, right? That's a critical element for us. Environmental attributes by virtue of which you become RE100, right? And I think space is going to be a constraint at some point in time, given the scale we are looking and our economy is bound to grow, and given the mission being laid out by Prime Minister of India. This further prevents corporate utilizing the roof space available with them from the national interest in reducing the carbon emission in case of brown power. Also, like under TOD, the during the peak hours, some of the states are not including those peak hours under the net metering purview, which again means like states like Maharashtra, which again means that you are being constrained on developing the solar to the tune you can do. States like Gujarat, for example, they are best states, I mean, in terms of the policies to work with. But then states like Gujarat, wherein the wheeling charges are so high, you can't go on a capex model, OPEX model. You have to go on a capex model, which again for small warehouse builders put a constraint because the upfront cost is pretty high. So with all of this, it is understandable that there is a conflicting interest between what the policy states and what we are putting as a national interest. So practically speaking, we should put the climate interest at the forefront, thereby clearing all such ambiguities and pushing states to implement policies our ecosystem. So
Thank you. Thank you, Mr. Akhilesh. Uh, now we have Mr. Akash Singh, uh, and I'll request him to be very concise and very to the point for this question. That for a renewable energy service provider, what are the policies do you think should be modified, or maybe some new things can be included?
Hi. So definitely, as Akhileshwarji touched upon, a couple of things for us to note is one, the wheeling charges in some states are higher. For example, in Gujarat, where there's resource rich, it costs more to just wheel power through open access in OPEX mode. Another thing that as a RE developer we are looking at is consistency of policy across states. For example, let's say for somebody like Flipkart, who has operations across multiple geographies in India. So if let's say we do a power purchase agreement, we do a PPA for the state of Maharashtra, that same set of rules will not apply to UP, will not apply to Telangana, and that creates a whole that creates a whole barrier in terms of people being able to adopt RE, which is the lowest hanging fruit right now as we stand. So consistency of policy across states, I think, would be my number one number one pitch to the government.
Fine. Thanks. Thank you, Mr. Akash. And I believe that we have overshot the time which was initially there in the agenda. I'll request Ms. Shakshi to let us know that if we can take questions from the participants, or would we like to answer them separately? Over to you, Ms. Shakshi. Uh, Ms. Shakshi, can you hear me?
Hello, good afternoon, sir. Sakshi has been facing some issues, so I'll be taking over for Sakshi, filling in for Sakshi now. Thank you so much for such an insightful session. We will now be screening some questions that have been posted by the audience.
Uh, Speakers, if anyone of you would like to take up this question, please go ahead.
Yeah, I can take that. So that's a great question, actually. If well designed through the passive measures, then the energy efficiency and then the renewable energy piece, it is possible to maintain it. Now, what the facility management team needs to know is how do we you keep the solar or the wind or the biogas that has been installed to be maintained at optimum. So they need to have the technical know-how to manage the common systems. Also, if common areas, and I talk from residential perspective, common areas are more fan based cooling rather than ACs. And AC maintenance, if you have done AC, then 5-star ACs and the management of that, common area lighting systems, and how do you manage the facility, how does the facility management process help in keeping it in an enhanced and optimum fashion. That's important. The other is, while you may have installed the pumps and the lifts, the maintenance of pumps, lifts are also very critical. And Many may not know the connection between water and energy. I mean, there is an excess, everybody knows, but just calling it out here is that if the water need increases and if people remove the aerators, then the pumping cost increases. So there is or if people are using RO, then water wastage is there, then more pumping costs. So there is a linkage between many of these. So there is a lot of thing around the how facility management also communicates to the end customers. So whether it is a tenant in a leased property, or whether it is a resident who is a flat owner, what are the measures that a facility management company needs to continuously do to ensure that these buildings are net zero energy, water, and waste. So there is a continuous engagement that is, and that's very difficult. It takes a lot of effort. So it would mean housekeeping training, equipment maintenance, and so on. So it is an effort, but needs to be done anyway for optimizing costs. And facility management people now understand this.
Thank you, Dr. Sunita. The next question, further, how when can we start the journey of converting existing building stock to net zero scenario? I'll request Miss Ashika, if she is there, because she spoke about existing building conversion. If you'd like to take up this question.
Yeah, exactly. It's a very valid question because in India, most of the existing building stock now would stand for 2050. It's important to look into the existing buildings. The first thing is, as we design a building, there should be audit of the building with similar sophisticated procedures. So it can have the audit of the design, the audit of the fabric, the audit of mechanical systems, electrical systems, and moreover, the pattern of the building, the occupant pattern and usage of the building. So once we map the existing building scenarios, then we can compare it with the future targets, or we can identify the energy efficiency options that may be able to implement. And at the same time, cost would be the factor. So we have to keep three things in mind. One is the net zero target that our organization has, or the country has. And second thing would be how much you are going to spend on it. And third thing would be the efficiency of the strategies that you are choosing and the applicability of these strategies. If we can have answers for all these three, then we would be able to successfully do a retrofit of an existing building.
Thank you, Mrs. Ashika. Uh, can we take more questions?
Yes, what is the best kilowatt per area thumb rule data in industrial and domestic buildings?
Okay, I believe this but next question, which is kilowatt per area, there are certain standards which are already available, ASHRAE standards through which you can study these things.
Yes, and also either you can go for the earlier targets published by BE. It's no more a part of ECBC right now, but still you can refer for different buildings. And otherwise, you can go for the EPI ratios mentioned in any other rating systems like GRIHA or LEED. Or there are no mandatory targets in India as of now, so it's purely voluntary that you can.
Okay, I think one more question we can take in this session. Uh, what could be the reason for not implementing in district cooling plants in India? I'll request Mr. Alok Panigrahi if he can very briefly answer this question. What are the impediments?
Okay, see, I would say in India, definitely it has started, but it didn't gain too much of momentum because in India, we need to understand the geographical as well as different perspective that it is not that much. It is not that much easy for us to implement because at the policy point of view, at the same time coming up with a requirement per se, it is different from different perspective. So probably in the coming days we will have a better understanding about implementing district cooling plant across regions. But right now, from the feasibility perspective, it is not a better way to go for it. But yes, if it can be done, then definitely there is chances that we could able to save almost more than 50% of the load requirement in the cooling per se.
Thank you, Mr. Alok. Uh, I think with that we have concluded with our questions. I'll thank all of our experts for their valuable insights and suggestions. And over to you, Ms. Ella.
Thank you so much, sir.
Thank you.
Thank you, audience and our esteemed panelists. With this, we have come to the end of this virtual event, and a very special thanks to both our moderators, Mr. Sharif Khamar and Mr. Yatin Chaudhary, for superbly managing the session. Your expertise and guidance have greatly enhanced the quality of the discussion. Our gratitude to all the speakers for taking the time out from their busy schedule for this key industry initiative. A big shout out to our attendees for extending your time and support for the event. Thanks to our partner Sunshore for their immense support to organize this event. As we conclude this event, we assure you that we will be back soon with more exciting sessions. The floor is now open for networking. Thank you, everyone.
Thank you.
Thank you.